Hello everyone, I am Ankit Gumaste. I am currently pursuing my bachelor's in electronics and communication from SDM College of Engineering and Technology. My USN is 2SD20EC015. Today in this video, we'll see selective repeat ARQ protocol. We'll be simulating this in the C language using the VS Code editor. Before simulating the code, let us take a brief look at the theory. The OSI architecture has 7 different layers, and the data link layer is the second layer from the bottom. It is mainly responsible for node-to-node delivery of the data. Its major role is to ensure error-free transmission of the information. Some of the functions of the data layer include framing, addressing, error control, flow control, and access control. The selective repeat ARQ protocol that we are going to discuss is a part of flow control. The flow control is a technique that allows two stations working at different speeds to communicate with each other. Let us take an example of a sender and receiver. Suppose the sender is able to transmit 100 frames per second, whereas the receiver is only able to receive 50 frames per second. In this situation, the flow control of the data layer restricts the number of frames the sender can send before it waits for the acknowledgement from the receiver. In flow control protocols, basically we have two types. One is for noiseless channel and the other for noisy channel. In noiseless channel, we have simplest and stop and wait protocols, whereas for noisy channel we have stop and wait ARQ, go back N ARQ, selective repeat ARQ. The last two, go back N ARQ and selective repeat ARQ, is a part of sliding window protocol. In sliding window protocol, basically we can send multiple frames at a time. The number of frames to be sent is based on window size. Each frame is numbered, that is, we call them the sequence number. Let's see the sliding window protocol. Let's say I have a sender and receiver and my window size is 3. Initially, my sliding window will be over here for this 0, 1 and 2. Initially, the sender sends 3 data frames. Then when the receiver sends acknowledgement, the sliding window moves further. Now let us take a look at selective repeat ARQ. Selective repeat ARQ, we only resend the data frames that are damaged or lost. If any frame is lost or damaged, then the receiver sends a negative acknowledgement to the sender, and if the frame is correctly received, it sends back a normal acknowledgement. Sometimes instead of sending a negative acknowledgement, no acknowledgement is sent. In this situation also, the sender interprets it as the transmission error. An example of selective repeat protocol. Let's say my window size is 4 and I have a total of 11 frames. The sliding window initially is here for 0, 1, 2, 3. As we can see, the sender sends the 4 frames initially. Next, once the receiver sends acknowledgement for, let's say, frame 0, the sliding window moves further. Let's say acknowledgement from frame 2 does not reach the sender. In this situation, we can see that frame 2 is retransmitted. In this situation, only the frame that has an error in transmission is retransmitted, not like the go back and ARQ where the whole window is retransmitted and the rest of the transmission are carried out. We are going to see this how this happens in the simulation part. This is the code for selective repeat ARQ protocol. In this, I have defined a structure that has a sequence number and acknowledged bit, and then we have final data. I have done the sender such that when once the sender sends the data may not reach the receiver side. The possibility for erroneous transfer is 25%. Then we have receiver. The receiver always sends the acknowledgement to the sender once the data is received properly. And in the main function, we take the inputs such as frames, window size, etc. Let's enter the number of frames. In this, let's take an example for 11 frames. Enter the window size. Let us take the previous window size only, that's 4. And this is the output that we have received. The sender initially transmit the frames same as window size. Then it receives the acknowledgement from the receiver. In this example, the 3 frames successfully transmitted and the frame 3 is lost. As we can see, again frame 3 is sent along with successive frames, where the total number of all the frames are sent. And similarly, in the receiver part, we can see that whenever the frame is received, the acknowledgement is sent from the receiver. Frame 0 received, acknowledgement from frame 0 sent. Frame 1 received, acknowledgement for frame 1 sent, and so on. Thank you.